Hi, welcome to Maths classes. Today, let's solve question number 1 in exercise 2.1 in the chapter Polynomials of class 10 NCERT Maths. Before starting the exercise, let's understand what is meant by zeros of polynomial. Zeros of polynomial. Generally, a real number k is said to be 0 of the polynomial p of x if p of k is equal to 0. What is the meaning of this? Suppose, let us consider example p of x is equal to x square minus 3x minus 4. This is a quadratic equation. We all know this. See, x square minus 3x minus 4. They are telling the 0 of the polynomial p of x. When k is said to be 0 of the polynomial p of x, if p of k is equal to 0. Let us take x as 1 here. Let us substitute 1. That means p of 1. We are finding p of 1. This is p of x. We are finding p of 1. P of 1 means in the place of x you should substitute 1. 1 square minus 3 into 1 minus 4. 1 square is 1. 1 minus 3 minus 4. You got 1 minus 7. That means minus 6. So, p of 1 is what? Minus 6. We did not get p of 1 as 0. So, 1 is not the 0 of the polynomial. Here, if you see, we have substituted x is equal to minus 1. P of minus 1 is equal to minus 1 whole square minus 3 into minus 1 minus 4. What do you get? Minus 1 whole square is 1. Minus 3 into minus 1 is minus 3 minus 4. That is equal to 1 plus 3 minus 4. That means 4 minus 4 is equal to 0. So you got p of minus 1 as 0. So you can tell that minus 1 is a 0 of the polynomial. So when you substituted x is equal to minus 1, p of minus 1, that is p of x, became 0. So minus 1 is the 0 of the polynomial. Similarly, you know that this p of x, x square minus 3x minus 4 is a quadratic polynomial. Because degree is 2, you will have two solutions. Zeros of the polynomials are nothing but the solutions. So, one solution. So, one zero of the polynomial is minus 1. You will have another 0 of the polynomial. You have substituted p of 4 here. That means x is equal to 4. Then you got 4 square minus 3 into 4 minus 4. 16 minus 4 is 12. 12 minus 12 is 0. So, p of 4 is also 0. So, 0 for p of minus 1 is equal to 0, p of 4 is equal to 0. So, minus 1 and 4 are the zeros of the quadratic polynomial. As it is a quadratic polynomial, you will have two zeros. If it is a linear polynomial, degree is 1, you will have 1 0. Zeros of the polynomial are nothing but the solutions. Okay. Now, let's understand geometrical meaning of zeros of the polynomial. See, you have equation 2x plus 3. Polynomial is 2x plus 3. You can do trial and error method. You can substitute x as 1, p of 1. Then you can substitute p of minus 1 and check. This is one method. What is another method? If you make this equation to 0, you will get 2x is equal to minus 3, x is equal to minus 3 by 2. This is the 0 of the polynomial. Let's substitute and check. P of minus 3 by 2. 2 into minus 3 by 2 plus 3. 2 gets cancelled. Minus 3 plus 3 is 0. So, this is another way of finding 0 of the polynomial. And trial and error method is another way. Okay, minus 3 by 2 is 0 of the polynomial. This we know. Now, if you plot a graph for this polynomial 2x plus 3, let x is equal to minus 2 plus 2. You got values y is equal to minus 1, 7. So, when you plotted the graph, this is the graph. So, if you observe, graph intersected x-axis at minus 3 by 2 comma 0. So, this x coordinate of this point is nothing but the 0 of the polynomial. That means the point where this line intersected x-axis. We should check that point. X coordinate of that point will become 0 of the polynomial. Here, this is the line 2x plus 3. This line intersected x-axis at minus 3 by 2 comma 0. So this will become, x coordinate of this point will become 0 of the polynomial. Minus 3 by 2 is a 0 of the polynomial. If you solved here also, you got minus 3 by 2. By trial and error also, you got minus 3 by 2. If you plot the graph also, it met x-axis at minus 3 by 2 comma 0. So you should see the point, x coordinate of the point where the line met x-axis. Then you will find the 0 of the polynomial. 0 of the polynomial p of x are precisely the x coordinates of the point where the graph y is equal to p of x intersects the x-axis. Okay, let's understand with another problem. See, p of x is equal to x square minus 3x minus 4. If you observe the graph, it met x-axis at 2 points. One point is minus 1 comma 0. Another point is 4 comma 0. You should see the points where it met x-axis. So, this is important. You should see the points where the graph met x-axis. It met at minus 1 comma 0, 4 comma 0. The x coordinates of these points. X coordinates of minus 1 comma 0 is what? Minus 1. So this is 1 0 of the polynomial. Here at 4 comma 0 also this graph met x-axis. So 4 is another 0 of the polynomial. So minus 4, minus 1 comma 4 are zeros of the polynomial p of x. Zeros of the polynomial p of x. This is quadratic equation, x square minus 3x minus 4. So we will have 2 zeros. So number of zeros is what? Number of zeros is 2. It met at minus 1 comma 0, 4 comma 0. X coordinates of these points are nothing but zeros of the polynomials. If they are asking number of zeros, here this is 1, this is 1. You will get 2. See, let's solve. This is the graphical method. Let's solve it normally and find the zeros of the polynomials. X square minus 3x minus 4 is equal to 0. That means x square minus 2x. How can you split it? My 4 and 1. 4 into 1, 4 you will get. So you can write 2 2s are 4. Another way is 4 1s are 4. 4 minus 1 is 3. So you should write what? By splitting method, you can write as x square minus 4x plus x. Here you have minus 3x. So you should write minus 4 plus 1. Minus 4 is equal to 0. In these two terms, taking x as common, you will get x minus 4 plus 1 of x minus 4 is equal to 0. X minus 4 if you take common, in here, you will get x plus 1. So, you got x square minus 3x minus 4 is x minus 4 into x plus 1. If you make x minus 4 as 0, you will get x is equal to 4. So, this is one solution. And you get x minus x plus 1 here. Make it 0. X plus 1 is equal to 0. X is equal to minus 1. So, minus 1 is another solution. These two solutions you got 4 and minus 1. These are nothing but zeros of the polynomials. If you observe by graphical method also, you got minus 1 and 4 are the zeros of the polynomials. So, these are the ways you can find the zeros of the polynomials. Zeros of the polynomials are nothing but the values of x for which the polynomial becomes 0. The graphs of y is equal to p of x are given in the figure 2.10 for some polynomials p of x. Find the number of zeros of p of x. These are the graphs. For each graph, we should tell the number of zeros of the polynomial. See, we already know that the zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x-axis. That means, if you observe the graph here where the line intersects x-axis, we will get a point. The x coordinate of that point will become the number of zeros, the zeros. See, in the first graph, if you see, here the line did not intersect x-axis at all. So, number of zeros here is, in the first graph, number of zeros you will get as 0. Number of zeros of this polynomial p of x is 0. This is the polynomial p of x. When it is represented, it is in the graph, we got this. Here it did not intersect x-axis. So, number of zeros is equal to 0. Next question. If you observe this graph here, this is the graph of the polynomial p of x. Check where did it intersect x-axis? Here. That means how many times it intersected x-axis? Only once. So, number of zeros is 1. X coordinate of this point is nothing but zeros of the polynomial. It intersected only once here. So, number of zeros for the second graph is, number of zeros of this polynomial p of x is 1. Now, let us solve third question. If you observe the graph here, it intersected x-axis or not? Yes. Here it intersected here and here. At 3 places it intersected x-axis. So, number of zeros will be 3. So, number of zeros for this graph, for this polynomial p of x is 3. One point is here, it intersected x-axis, here it intersected, here it intersected. So, we will get 3 as the answer. Now, see the next graph. See, here you got a parabola. It intersected at x-axis at 2 points. It intersected x-axis here and also here. So, at 2 points it intersected x-axis. So, number of zeros for this polynomial p of x will be 2. When you observe this graph, this is the graph here. It intersected at how many points? 1, 2, 3 and 4. It intersected at 4 points. This is first point, this is second point, this is third point, this is fourth point. So, we will get number of zeros as 4. Number of zeros is equal to 4. X coordinates of these points are nothing but the zeros of this polynomial p of x. Now, let us observe the last one. See, this is the graph here. We should see at how many places graph intersected, the line, the curve intersected x-axis. Here 1 point, 2, this is y-axis, so this will not be counted. 3, 1, 2 and 3. So, number of zeros for this polynomial p of x will be 3. Thank you for watching the video. Like, share and subscribe.